We are live. Hi everyone, welcome back to Geeks for Geeks practice. Today in this video we'll be discussing the Geeks for Geeks daily practice problem. The problem name for 21st of January was leaves to DLL. That is, you have to convert all the leaves of a given binary tree to a doubly linked list, and then you have to remove all those leaves. So this question previously has been asked in companies like Amazon and LinkedIn. So consider giving me a quick +1 in the chat if my voice is audible to everyone and my screen is visible, and then within some time I'll start once everyone joins, right? So if my voice is audible to everyone and my screen is also visible, so you can just consider giving a quick +1 in the chat, and then we'll start with the session today, right? So in this particular problem, what you have to do is, let's say you have been given this particular binary tree. Okay, if you have been given this particular binary tree, then the question says that you'll be given a binary tree whose size is n, so the number of nodes are n, and you have to extract all its leaf nodes to form a doubly linked list, which is starting from the leftmost leaf. So starting from the leftmost leaf, you have to move one by one. Hi Shaumya Chandra. So you have to move one by one such that you have to build a doubly linked list. So you have to modify the original tree to make the doubly linked list, and then also you have to do what? You have to remove the leaf node from the tree. You have to remove the leaf nodes from the tree. I'll be telling you how. So you have to consider the left and the right pointers of the tree to go to the previous and the next like for traversing in the tree, and then you have to make this doubly linked list, right? What does it mean? So let's say you have 1, then you have 2, 3, and you have 4, 5, 6, right? So what are the leaf nodes in this particular tree? In this particular tree, let me zoom in a little bit more. Okay, yeah, right. So for this particular tree, that is 1, 2, 3, 4, 5, 6, 7. In this, the leaf nodes are 4, 5, 6, and 7, right? So what I would be doing is, first of all, I need to erase all these leaf nodes from the tree. So the tree now would look like 1, 2, 3, and all the leaf nodes would get removed. After that, I'll make a doubly linked list in which 4 will be pointing to 5 and 5 will be pointing to 4. Then 5 would be pointing to 6 and 6 would be pointing to 5, and 6 would be pointing to 7, 7 would be pointing to 6, like this. It's a doubly linked list. So let me show you how. So basically 1 to 3 would be the tree, and after that what will happen? 4, 5, 6, and 7. This is how these are the leaf nodes from left to right. So this is how they would look like in a doubly linked list. If the problem statement is clear to everyone, please like the video and please consider giving a quick +1 in the chat. Is the problem statement clear to everyone? Please consider giving a quick +1 in the chat if the problem statement is clear to everyone, right? Is the problem statement clear to everyone? Just let me know a little quick in the chat. Let's say you had 1, you had connected 1 to 2, then 3, then 3 to 4, 4 to 5, then this, and then this, right? So in this case, what are the leaf nodes? This is a leaf node, this is a leaf node, this is a leaf node, this is a leaf node. So the now the new tree would look like this. That is 1 to 3. The tree would get modified in this format, and the doubly linked list would look something like this. Okay, like this. You have 4, 5, 6, and 7. This will be the starting point of, this will be the head of the doubly linked list. 4 will point to 5, 5 will point to 6, 6 will point to 7, and then you can also move back in this particular linked list. So this is how it would look like. So from left to right. Bhumika is clear with the question, and Soumya is also clear, right? Let's take the next test case. Also, just to highlight, this problem, as you know, has been asked in Amazon and LinkedIn, right? So it might also be possible that it must have been asked sometime in Microsoft as well. So basically, if you are targeting companies like Amazon, LinkedIn, Microsoft, Adobe, all these types of companies, so such type of binary tree questions and linked list questions are what you should expect in an interview. So that is why this problem becomes necessary to do, right? Now in this particular problem, let's discuss the next test case as well. So let's see the next test case. The next test case is 1, 2, 3, 4, and 5. Like this. Let me draw it for all of you. Okay, so the next test case is something like this: 1, then 2, then 3, and then 4 and 5, something like this. Okay, so in this particular test case, what are the leaf nodes? Can I say that the leaf nodes are nothing but 4, 5, and 3? These are the leaf nodes. So in that case, what will my tree look like? My tree would be nothing but 1 and 2. This will be my binary tree that would be left, and the linked list would look like this: 4, 5, and 3. Moving from left to right. 4 will point to 5, that is from 4 you can move to 5, then 5 from 5 you can move to 3. From left to right you are maintaining the order, then 3 to 5 and 5 to 4, like this. Let's see whether this is the correct answer or not. So in this particular test case, you can see that the tree that is left is 1 and 2, because you have removed all the leaf nodes, and this will be the order 4, 5 and 3, right? So if this test case is also clear, please write clear in the chat, and then we'll discuss that how to approach this particular problem, right? How to approach this problem, particular problem we'll be discussing, but quickly consider giving a like to the video and give a +1 in the chat, so that I know that this much part is clear, right? Up till now everything must be clear to all of you, right? So now the thing is that how will you approach this particular problem? So what you can do is, you know that you will be making all the leaf nodes, in a linked list, right? So it's clear to Soumya, Dweep. What about you, Bhumika, and what about others as well? Just let me know. Okay, so in this particular problem, what you have to do is you have to make a doubly linked list, right? You have to make a doubly linked list. So for that, can I say that I'll be having a head? I'll be having a head of that doubly linked list, and I'll be having a tail of that doubly linked list as well. Let me draw the tree as well. That is this one. One is connected to 2, 2 to 3, 3 to 4, then 4 to 5, then this, and something like this. Okay, what I would be doing is, I know that for going to the leaf nodes, I can see a lot of people are joining, so please like the video and please give a +1 in the chat if everything is clear up till now. Okay, so what I would be doing is, I can say that I need to traverse the tree. So what I can do is, I know that I have to print in which order. I have to maintain a doubly linked list in which format? In this format, like 4, 5, then 6, then 7, and then like this. Okay, like this. So which is the most suited traversal that I should do in such a way that first of all I find the leaf node from the left, then I move gradually towards the right. I move to left, then I move to the center leaf nodes, and then towards the rightmost leaf nodes, right? So what I can do is, I can say that I can traverse the tree using a pre-order traversal, right? Using a pre-order traversal. What I can do is, I can use a pre-order traversal. What is a pre-order traversal? Anyone would like to let me know what's a pre-order traversal? What do you do in a pre-order traversal? Can I say that it is nothing but root, left, and then right? This is the pre-order traversal that we do. If I'm correct, please write yes in the chat. Okay. After this, what I would do is, I would start from the root node. Let's say this is my starting node, right? Let's say 1 is my starting node. So I start from the root. Then I check that whether its left is existing or not. So yes, the left node for this particular one is existing. So I move down. Then I come to 2. What do I see? I've come to the root. I have come to this particular node, right? So I see that it still has a left child to it. So I'll say, okay, let's call for the left as well, right? Once I call for the left, so what is the thing about this particular 4? For this particular node 4, which is having value 4, it does not have a left child, it does not have a right child. So that means it is the leaf node. I know that it is a leaf node. Now one more thing is there. One more thing that you need to keep in mind. You need to, first of all, you need to maintain the doubly linked list. Secondly, you need to update your tree as well. So every time what you will be doing, every time you call a pre-order in a recursive format, every time you are calling the pre-order traversal, so what you are doing is, every time you are returning the root. What do I mean by that? So if I am calling for 1, like let's say if I have called for this particular node, right? If I call for 1, then in that case I should ultimately return 2, so that 1 is connected to 2 is justified, right? Or one is connected to 2. If every time I'm calling for 1's left, so the node, the function of pre-order should return 2, so that 1 is kept connected to 2. But what happens when I come to the leaf node? If I come to the leaf node and if I see that this is my current node, good evening Sushil and hi Shreya. Okay, so if this is my current root, okay, so this is what it is, neither its left is existing nor its right is existing, right? So what I will do is, I will say that if there is a node says that its left is also not existing and its right is also not existing, so that means it is the leaf node. So what I would do is, I know that now my tree would look something like this. Let me draw it for you. Now I know that ultimately my tree would look something like this. So I know that this 2's left would become null. So whenever I see a leaf node says that if this is the current node, that is the current leaf node, so that will have no left and right child. So in that case I'll return null. So I'll say that, okay, now this will point to null. This left would point to null. Okay, this is what I'll say. And what I would do is, I want to make a linked list. Notice that I want to make a doubly linked list as well, right? So how will I make a doubly linked list? So for doing that, I will simply see that currently what is my, is there anything in my linked list? No, currently my head is also null and my tail is also null. So if the tail of the linked list is null, if the tail of the linked list is pointing to null, so that means there is no node. So in that case, what will I do? I'll simply say that, okay, now let's add this particular node. So what I would be doing is I will say that my head is equal to nothing but the root, nothing but this current root. Okay, I'll say this, and I'll also say that this, since there is only one node currently, so I'll say like this, something like this. I'll make this node 4. Let me draw it here. Okay, so I'll make this node 4, and I'll say that this is here, this is my head of the doubly linked list, as well as this is my tail, because there is currently one node. So I'll say, okay, tail is equal to root as well, right? Because initially I can see that if my tail was null, if my tail or head both are null, so that if I do not have started my building my doubly linked list, in that case, if that is the leftmost node, so in that case I'll say that my head and tail will be pointing to the same node, right? Once I'm done with that, so what would I do? Let me show you. So I have moved up till here, right? I have moved down up till this point using the pre-order traversal. I have moved to root, then from root I moved to down. Okay, so from this, what's happening is my tree is getting updated, because now this pre-order function would return a null. So that's why what will happen, this 2 would get connected to a null, right? Because if that is the leaf node, so in that case I am returning null as the root. And if I am calling for 1 as the parent, then its child, it will return 2. The pre-order function will return 2, so that is why 1 will be connected to 2 still. So only the leaf nodes would get removed like this. Okay, after this, what was where were we in the pre-order traversal? We were here, then we moved back to 2, right? And then we will call for the right child. So is there a right child? Yes, there is a right child. Now I will say that do I have head and tail? Yes, I have, right? I have head and tail as well. So I will say that's what is the new node. The new node is 5. So the current root is what? I will say that the current root node is 5. Okay, so this is the current root node. So what I will say is that my head is there, my head is also there, and my tails are also there. So how will I make a doubly linked list? Can anyone let me know in this part? How will I write to make a doubly linked list in this particular part? How will I do it? Okay, notice that this is my head as well as my tail, right? Currently this is my tail as well. So I'll say that my tail, my 4 is my tail. So I'll say that tails right is equal to root. So that simply indicates me, that will simply help me out in doing what? That will simply help me in saying that, okay, now 4 will point to this particular 5, right? This is what I would do. Another thing that I need to do is this 5 should also point to 4, right? Because this is a doubly linked list. If this much part is clear, please consider giving a +1 in the chat, because I want to know your feedback as well. Up till now, whatever I've taught, is it clear? Please write clear in the chat, right? After this, I am at this node. This is my root. So what I need to say is my roots left. I also need to say that my roots left is equal to nothing but the tail, the current tail that I have. This is the current root. This is the current root. So I'll say that since this is the current root, so I'll say that its left is pointing to 4. That is what I want. So that is the current tail. It should point to the current tail. Okay, this is what I should do. Now this linked list is getting updated. Okay, now this linked list has got updated. Now I'll say that the head will remain same. I'll not be touching the head, because in the end I have to return the head. Okay, and I will say that now this root was okay, but I'll also say that this was my root. Okay, this was my root. So I'll say that after this, my tail is equal to root, because what is the thing, this is not my tail anymore. The current node is not my root. Will give 2. Root will give 2. What do you mean by that, Chirag? Can you just explain a little bit? So this will be my tail. Okay, this will be my tail. Root will not be 2. This particular part, I'm talking about this. Once I am at this particular node, if this is my root, I've called for the right subtree, so that is why root will no longer be 2. I'm currently at 5, so the current root will be 5. Okay, it will not be 2. I hope that it's clear. So I'll say that, okay, my tail is getting updated to this. So first of all, I'll say that, okay, tails right, that is, this was the current tail. So 4 was the current tail, because initially I did not have 5. So I'll say that 4 will point to 5, that is tails right would point to root. Then I'll say that roots left, that is the current root 5 would point to 4 as well. So current roots left would point to tail, and after that I'll update my tail with the root. This is what I would do. Now what I would do is I'll keep on continuing my traversal. So what do I see? I see here, I observe one thing here, that since I am at this particular node, so this is nothing but a leaf node. So I'll say that okay, since this is a leaf node, so in that case, whenever I will be calling back the pre-order function, so I'll be returning from this pre-order function, so I'll be returning null. So I'll say okay, let's return null. Now I move up, I move to 1. From 1 I go to 3. So since I go to 3, so I move from 3 is my current root, then I move to its left child. So since I move to its left child, what is the left child? Now the left child is 6. So 6 is my current root. So I'll say that okay, my current root is 6. So what do I observe with 6? What do I observe with 6? I observe with 6 that 6 is a leaf node, right? 6 is a leaf node. So what does it mean? That since 6 is a leaf node, so that is why I will be adding it in my linked list. Okay, so what will happen? My root node is 6, and you need to notice something. This is my tail. My tail is 5. So 4, from 4 I needed 5, like it was like 4 5 6 7, like this, right? So that means my tail is pointing to 5. So what does it mean? So my root is 6. So I'll say that okay, tails right, this is the current tail. Tails right would point to root. That will mean that I'm making this 5, that is the current tail, point to 6. This current tail is pointing to 6. Another thing that I would do is that this is my current root. Okay, this is my current root. I'll also say that this needs to point back because this is a doubly linked list. So that is why I'll say that okay, roots left would point to tail, that is 6 would point to 5 as well. And after that I will say that this 5 will no longer be in my tail. If this much part up till now is clear, please write clear in the chat. Please consider giving a clear in the chat so that I know that up till now the things are clear, right? So I'll say that okay, now my current tail would update to the root. Now 6 will be my root. So okay, so that's why this will no longer be the root. The root will be 6. 5 will no longer be the root, and the root will be 6, like this. Okay, after this much part would be done again. So now what will happen? What would happen? I'll move back up. So this is nothing but a pre-order traversal that I'm doing. So before moving, since this is a null root, this is nothing but leaf node, so that is why it will point to null, because I will return null from here. So it's clear to Shubham and it's clear to Chirag. What about you, Shreya? You can let me know. And what about you, Nana? Okay, after that I go to 3. From 3 I go to 7. So I have this 7. So 7 is also a leaf node. So my current root is 7. So I'll say that okay, current node is 7. So I'll say that okay, current root is 7. Current root is 7. So I'll say that okay, my tail's left pointer should point to what? My tail's left pointer should point to root, that is 7. And then after that I'll say that okay, my roots right pointer like no, tail's right pointer, okay, sorry, tail's right pointer, because from 6 you are moving to 7. So 6, the right of 6 would be what? The node towards the right of 6 would be nothing but the root, that is 7. And I'll say that okay, roots left, that is from 7 left. So if you are moving back, so that will be what? 7's left would be 6. So I'll say that okay, roots left would be pointing to the tail. Then I know that since I have inserted a new root, so that is why what I would do is I will say that I need to update my tail. So the tail will be nothing but tail will become the root. I'll say that okay, tail becomes the root. So this would happen. Now this was my root and this will also be my tail, okay, because I need to update my tail. This would be the order in which it would be done. Now since I am doing what? Since this is the leaf node, so that is why I am returning null from here. So that is why this would become null. And you can see that this is the head of the linked list. This is the head of the linked list that we have, doubly linked list that we have, and we have its head, we have its tail. In the end we just need to return the head. And you can also see that my tree has got updated, right? You can see that my tree has got updated. It has got updated like this. So all these are pointing null. So this means once, 1 is pointing to 2, 2 is pointing to 3. So now my tree would look something like this. Okay, this is also the same, but I've just removed the null part. So you can assume that if there is nothing written, so it is null. Please write a +1 in the chat, a quick +1 in the chat if this part is clear to all of you. Since you are traversing, is this part clear? You have made a doubly linked list using the head and the tail concept. Basically, whenever it's the first time, so you will do it like that. Let me show you the code part a little bit, and then we will be discussing it further. What I've done is basically I'll be given a function that is convert to DLL, and in that function what will happen? My tail is equal to null. So I'll mark my tail as null and head as null, indicating that currently I do not have anything in my linked list. Then I'll call the pre-order for the root, and in the end I'll simply return the head of the linked list, right? I'll simply return the head of the doubly linked list, right? This is what I need to do. In this question, I need to return the head of the doubly linked list that I've made. So if my root is null, what happens when my root is null? If the current root is null, then I'll return null, or I'll simply return root. Okay, this is what I will do. Right? If it is null, so I'll return null. If the roots left is null and the roots right is also null, so this means that we are at the leaf node, right? We are at the leaf node. This is nothing but the current like this means that root is the leaf node. Okay, root is the leaf node. Like this, root is the leaf node. This will simply mean that my root would be the leaf node if this is the condition satisfied, if the left pointer is null as well as the right is null. So in that case, what does it mean? It means that the current root that I am at, it is leaf node. So I would simply say that in that case, also notice that this pre-order function is every time returning a node. Okay, what I would do is I will check if my tail is equal to null, indicating that currently there is no node, there is no node in the doubly linked list, right? In doubly linked list. So that means that the doubly linked list would be currently empty. In that case, I will say that head is equal to root, because head would also point to the root and tail would also point to the root, because this is the very first node that I am inserting. Otherwise, if the DLL exists, okay, if the DLL exists, so that means I'll be having a head. I'll not touch the head. I'll not touch my head of the linked list. I'll say that tails right is equal to root. I'll simply say that tails right is equal to root. That is the current tail that I have. I have not updated my tail. So the current tail's right pointer, the last node that I have, its right pointer should point to the root, because we are expanding a doubly linked list. After that, the current's root left pointer should point to the tail, right? So that it can be made as a doubly linked list. And then I'll say that tail is equal to root. So I'll update my tail to root, so that I can say that, okay, now my tail should point to the current root. Okay, this part I have explained just before, right? In the dry run. Then after that, if I am in this particular if condition, so that means if this is a leaf node, if this current root is a leaf node, then notice that I am returning a null. So that means that the next time when I'll come back to my parent, so in that case, its left would point to null, because this pre-order function, if I'm calling, if suppose that I was at 3, then it had suppose that I was at 2, then 2 had what? 2 had children, something like this. Let me check. 2 had children what? 2 had children, let's say 4 and 5, right? So if 2 had children 4 and 5, so both of them are root nodes. So that is why 2's left would point to null. This pre-order function would be null, because 4 is a leaf node, so this will return null. And if this, so 2's left would also point to null and 2's right would also point to null, right? Like this. So that's why you are doing this thing, and this is nothing but the pre-order traversal. So first of all, I check for the conditions of root, then I am calling for the left child, and I'm updating my left. If it is not a leaf node, then this parent child relationship would not get affected. If I'm at the current leaf node, so that means the parent would now point to null. Both the left and the right pointer would point to null. And in the end, if that is the situation, if the situation is that I am not at the leaf node, if I am not at the leaf node, then I do not want to disturb the relationship. In that case, I will simply return the root, because if the situation is something like this, if assume that the situation is like this, let's say 1 is pointing to 2 to 3, then 4 and 5, something like this. In that case, if this is the current node that I am at, okay, so this is not a leaf node. So in that case, what will I say? That if this is the case, so in that case, one should always keep on pointing to 2. In that case, I should not disturb the relationship, right? Please consider giving a quick +1 in the chat if this part is clear to all of you. Now, talking about the time complexity for this particular code, let me just... Okay, the time complexity would be order of n, because we are just doing an pre-order traversal, and the space complexity would be nothing but the order of height of the tree that we have, or you can say order of log n. So if this much part is clear, if the problem statement and everything is clear, please write a +1 in the chat, or please write clear in the chat, so that I know that the problem statement is clear to everyone, right? Is it clear? I hope it's clear to Nana, it's clear to Aman, it's clear to Soumya Dweep, it's clear to Shreya, it's clear to Bhumika, right? Is everyone clear with this? You can just write a clear in the chat. Just an acknowledgement would help me, right? So this is what I have done. I have explained the problem like in detail. Basically, again, if I had to explain, tail and head of the linked list would be pointing to null. Then I'll call the pre-order. what I do in pre-order is root left and right. So first of all, I'll check the root. If the root is null, so that means I will return null. If there is a leaf node, so what is the condition for leaf node? If there is a leaf node, so it means that its left and the right child would be null. So if that is the case, so I'll check if I have not made a doubly linked list. If the doubly linked list has not been started to mate, so that means that this is the leftmost leaf node. So in that case, I'll mark my head and tail to the root, okay, because both of them should point to root. After that, if the doubly linked list is already existing, then the current tail's right should be the root. That is, I'm expanding my linked list, and its root's left should point to the tail. So the root's left would point to the tail, basically indicating that the current root's left would be pointing to the tail. So that is how the doubly linked list previous and the next relationship would be established. And then I'll say that okay, tail is equal to root, like this. Let me say something like this. Okay, this is what I'm explaining. Let's say if 4 was my current head, just ignore the head will remain the same. So let's say this was my head, then I had the current root, and it was 5. So this is also my tail, notice that. Okay, so I'll say that tail's right is equal to the current root. I'll say that okay, tail's right is equal to the current root. This is what I would say. I'll also say that root's left is equal to tail, because I need a backward relationship as well. So this relationship is established. Then I would say that okay, now this linked list has got expanded, doubly linked list. Now my tail would also move here, right? Because this linked list has got expanded, there is one node added. So now this would be my tail, right? So that is why what I will do is I'll say tail is equal to root. So now this would not be the tail anymore. Basically this becomes the tail, right? So this is what I've done. If the problem statement is clear, everything is clear, so please like the video and consider giving a quick +1 in the chat. Please give me a +1 in the chat if now everything is clear, right? Everything is crystal clear to everyone, right? So this is what I did, just explaining the code again. So I've returned null if I'm at the leaf node. So that means that my parent should be pointing to null because I'm removing the leaf node. This is nothing but the removal of the leaf nodes. Then what I've done, I've called the pre-order traversal. So that is why I've called left for the left and the right child. Basically this will not disturb the relationship whenever I am in the middle nodes, because those middle nodes would never get affected because I'm returning the root. In that case the relationship would remain the same. But if I'm calling for the left child and the right child, and suppose they are returning null, so that means that like what will happen, all the leaf nodes would get removed, because now their parent would be pointing to, that is 2, would be pointing to null instead of 4 and 5, right? It's like this. So it's left like 2's left was 4 and 4 would return null, right? So that's why 2's left would be null and 2's right was what? 2's right was 5. So that is why 5 would also return null because it was the leaf node. So in that case 2 will be pointing to itself, and let's suppose you are at 1, so that means you were never a null. So that's why you will if you had called for 1, so 1's left child was 2 and 2 was never a leaf node, so that's why you will return the root. So that will not disturb the relationship in my tree. So that's it for this particular question. Talking about this problem, so this problem was asked previously in, I guess, Amazon. It was also asked in a company like LinkedIn. And since it was asked in LinkedIn, so you can also consider that it must have been asked sometime in Microsoft as well. So these are the companies that if you are targeting, so this is a must do problem for that. Also telling you something, so the problem of the day for today is distinct palindromic substrings. So once you submit this particular problem has been asked in LinkedIn, Make My Trip, Ola Cabs and SAP Labs. So try to solve this particular question and come back to this video today. And once you submit this particular problem, so come back to this video once the session is done and write in the comments that I have solved the problem of the day for today. I'll be taking this tomorrow at probably 3 p.m. In the afternoon. So that's it from my side for today. If you have any feedback, so you can comment down that in the comments and I'll be looking into your comments. Thanks a lot everyone for joining, and jate jate give me a +1. Thanks.